Ever wondered what happens when you break down the universe to its smallest, most fundamental parts? Well, buckle up, because we're about to dive deep into the heart of the cosmos, where the rules of the game are unlike anything you've encountered before. Welcome to the realm of quantum physics, where the seemingly impossible becomes possible. Quantum physics, in its simplest form, is the study of the very small. It's the science of particles tinier than atoms, particles that form the building blocks of everything we see around us. But here's the catch. These particles don't play by the traditional rules of physics. Instead, they dance to the beat of a different drum, a drum that beats with the rhythm of probability and uncertainty. You see, in the world of the very small, things are not as they seem. The classical physics that we know and love, that tells us a ball thrown up will come down, takes a back seat. In its place, we find a new kind of physics, one that tells us particles can exist in multiple places at once, can spin in two directions simultaneously, and can even affect each other instantly over vast distances. It's a world that defies our everyday intuition, a world that seems more akin to magic than science. And yet, this seemingly bizarre world is not some fantasy. It's as real as the ground beneath your feet, and it's the fundamental reality of our universe. Quantum physics is not just a theoretical curiosity. It's the science that powers our modern world, from the transistors in your smartphone to the lasers in your DVD player. So why is quantum physics so important? It's because it provides us with the deepest understanding of the universe we have. It peels back the layers of reality to reveal the strange and beautiful truth underneath, a truth that's as fascinating as it is complex. So welcome to the bizarre, fascinating, and often counterintuitive world of quantum physics. Get ready to leave your comfort zone and embark on a journey into the heart of the quantum universe. Imagine playing a game where the rules constantly change. Welcome to the world of quantum particles. These tiny subatomic entities are the star players in the grand game of quantum physics. And let's just say, they don't play by the rules of the conventional world. Quantum particles are notorious for their unpredictable behavior. They are like the rebellious teens of the atomic world, refusing to conform to the norms of classical physics. Instead, they dance to the tune of quantum mechanics, a realm where predictability takes a back seat. This unpredictability is best defined by the Heisenberg uncertainty principle. Named after the German physicist Werner Heisenberg, this principle states that it's impossible to precisely measure both the position and momentum of a particle at the same time. The more accurately we know one of these attributes, the less accurately we can know the other. It's not due to any technological limitation, but a fundamental aspect of quantum mechanics itself. It's like trying to pin down a ghost. The harder you try, the more elusive it becomes. Just when you thought quantum particles couldn't get any weirder, they showcase another bewildering trait. These particles exhibit a dual nature, behaving both as particles and waves. This is known as wave-particle duality. One moment they're a particle, confined to a single point in space, and the next, they're a wave, spread out over several places at once. It's as if they're playing hide and seek, revealing themselves only when they choose to. So what does this all mean? Well, it means that the quantum world is a realm of possibilities, where particles can be in multiple states at once, only deciding on a single state when observed. It's a world where the rules of the game are constantly in flux, and the players are as unpredictable as they come. In the quantum world, it seems, the only certainty is uncertainty. What if I told you that two particles can be interconnected in such a way that the state of one instantly affects the other, no matter how far apart they are? Welcome to the realm of quantum entanglement, a phenomenon so baffling that even Albert Einstein referred to it as spooky action at a distance. Imagine the world's most intricate dance, where two dancers, regardless of the distance between them, mirror each other's moves instantly. The steps of one dancer dictate the steps of the other. This is the essence of quantum entanglement. Two particles are entangled if the state of one immediately influences the state of the other, irrespective of the distance separating them. This makes it seem as though information travels faster than light, a concept that challenges our understanding of the universe. Quantum entanglement has been experimentally confirmed, making it more than just a theoretical marvel. The famous Bell's theorem experiments have shown that when two particles are entangled, measuring the state of one particle instantly determines the state of the other. This result defies classical physics and supports the bizarre predictions of quantum mechanics. Einstein, however, was not a fan. He believed that spooky action at a distance could not possibly be real, arguing that there must be hidden variables that we're not aware of. Yet decades of experiments have only cemented the reality of quantum entanglement, leaving Einstein's objections in the realm of philosophical debate. The implications of quantum entanglement are profound. It suggests that the universe is deeply interconnected in ways that we're only beginning to understand. It also plays a pivotal role in emerging technologies like quantum computing and quantum cryptography, where entangled particles can be used to process information or secure communications in ways that were previously inconceivable. Quantum entanglement, thus, transcends our traditional notions of space and time. It invites us to see the universe not as a collection of separate objects, but as a web of relations, where distant particles can be as deeply linked as two sides of the same coin. This is the spooky, yet beautiful face of the quantum world. Can you be in two places at the same time? Sounds impossible, right? Not in the quantum world. In this fascinating realm, there's a concept called quantum superposition. It's a fundamental principle of quantum mechanics that allows particles to exist in multiple states at the same time. Yes, you heard that correctly, at the same time. It's like having your cake and eating it too, except on a subatomic level. Think of a quantum particle as a spinning coin. While it's in the air, it's neither heads nor tails but both. Only when it lands, the outcome becomes certain. Similarly, a quantum particle can be in multiple states simultaneously until it's observed or measured. Then, like the coin, it chooses a state to be in. This brings us to Schrödinger's cat, a thought experiment that beautifully illustrates superposition. Imagine a cat in a box with a radioactive atom that has a 50% chance of decaying. If it decays, it triggers a mechanism that releases a lethal poison, killing the cat. According to quantum mechanics, until we open the box and observe, the cat is both alive and dead. It exists in a superposition of states. Now I know what you're thinking. That's not how reality works. If you leave your pet alone at home, it doesn't exist in a state of being both alive and dead until you return, right? Well, this is where the quantum world parts ways with our everyday experience. Quantum superposition doesn't align with our macroscopic view of the world, making it a perplexing concept to grasp. But it's this very principle of superposition that could potentially revolutionize our future technologies. Quantum computers, for instance, rely on this principle to perform complex calculations at speeds unimaginable with today's technology. So, while the idea of being in two places at once might challenge our understanding and experience of reality, it's a fundamental cornerstone in the enigmatic world of quantum mechanics. The superposition principle truly challenges our everyday experience of reality. Why should you care about quantum physics? Well, it's shaping the technologies of the future. So let's take a moment to ponder this, shall we? Quantum physics, despite its complex and often bewildering nature, is the cornerstone of some of the most exciting technological advancements on the horizon. One such example is quantum computing, a technology that harnesses the power of quantum bits, or qubits, to perform computations that would be impossible for classical computers. Unlike traditional bits, which can be either a 0 or a 1, qubits can exist in multiple states at once, thanks to the quantum principle of superposition. This allows quantum computers to process vast amounts of data simultaneously, potentially revolutionizing fields like artificial intelligence, drug discovery, and climate modeling. Then we have quantum cryptography, a method of secure communication that uses the principles of quantum mechanics to encrypt data. It's based on the idea that the mere act of observing a quantum system changes the system, a concept known as quantum disturbance. This makes it virtually impossible for a third party to intercept the data without being detected, offering a new level of security in an increasingly digital world. And let's not forget quantum teleportation, a concept straight out of science fiction. While it doesn't involve physically transporting matter, it does allow for the transfer of quantum information from one location to another, without any physical medium. This is achieved through a phenomenon known as quantum entanglement, where two particles become inextricably linked, such that the state of one instantly affects the state of the other, no matter the distance between them. Each of these technologies, while still in their infancy, holds the potential to drastically reshape our world. They could revolutionize how we process information, secure our data, and even communicate. Quantum physics, with all its peculiarities and paradoxes, is not just a field of abstract theoretical research. It's a rich, fertile ground for practical innovation.
So the quantum world, as strange as it may seem, holds the key to our technological future.
And that, dear learners, is your quick journey through the quantum realm. We've delved into the unpredictability of quantum particles, the spookiness of quantum entanglement, and the mind-bending idea of being in two places at once. We've also glimpsed how quantum physics is the key to future technologies. Quantum physics is not just a subject, it's a lens through which we can explore and understand our universe. Remember, as Richard Feynman said, if you think you understand quantum mechanics, you don't understand quantum mechanics. So keep exploring, keep learning, and keep questioning.